Okay, hello, welcome to our video on dimensional analysis. Hey, question, how many feet are in a yard? Well, it depends on how many people are in the yard. Get it? Feet. Yeah. Okay, excellent. Moving onwards. Here's what we're doing today. You're going to recognize that a wide variety of units are used in different measurement systems and be able to convert between units using the train tracks method. Train tracks is something we're going to try out. Okay, so hopefully at this point you already know that there was a craft called the Mars Climate Orbiter launched from Earth with the intention of going into an orbit around Mars and taking a lot of measurements that would help us understand the climate of Mars better. And so the plan was send the craft out flying and then put it on this specific trajectory so that it would end up about 226 kilometers above the surface of Mars. And that is approximately the altitude you need to be at to end up in a good orbit around Mars. Too far away, too high up, and you'll just keep going and won't make it around Mars. Too close, and you will crash land. And so, unfortunately, what happened was they ended up with a trajectory that was way too close. And they ended up coming in about 57 kilometers above Mars's surface, which was so close that the gravity then pulled the craft straight down and it crash landed on top of the surface. So, essentially that resulted in which is my face when I just lost a craft that cost $326.7 million. Right, so this is a very expensive project, and it blew up on Mars. Bummer. Why did that happen? Why did that happen? Well, it happened because of a problem with unit conversion. So what happened were there were multiple companies working on setting up this spacecraft, and one of them used English units, which are what we call the traditional units we use in the United States, like miles and acres and pounds. And everybody else was using metric, what we use in science, like kilometers and square kilometers and kilograms and such things. So because some of the measurements came in using different units, the numbers got all goofed up. They ended up getting too close and crash landing. So simple lack of conversion was something that caused a really big problem. Okay, so we are going to practice how to do these conversions, so hopefully you don't end up in that situation. And here's how we do them. So here's just some steps, and I'll show you how we do these steps. First step is you want to identify what is the unit that we're starting with. Right? There's some starting unit. And the second step is what do we want to end with? Right? So maybe I want to convert from miles to kilometers. Miles is my starting unit, kilometers is my ending unit. Then step 3 is find the conversion factors that you need. Sometimes they're given to you, sometimes maybe you look them up. But what is the conversion factor? For example, the conversion factor between miles and kilometers is there are 1.6 kilometers in 1 mile. That's the conversion factor. Then we set up train tracks. You'll see train tracks. It's just a way of helping us keep things in the right places. We do a little math. We cross out our units to check to make sure we've done everything the right way, and then we calculate. Okay, let's start off with let's just start off with a conversion factor definition. Make sure you have this note in your notes. A conversion factor, that's a multiplier that converts a quantity with one unit into an equal quantity with another unit. So conversion factors would be things like 1 foot equals 12 inches, 1 meter equals 3.3 feet, 1 day equals 24 hours, or $1 equals 0.84 euros. Those are all conversion factors that you might use. There's lots of everyday reasons, lots of science reasons to do these conversion factors. And, usually you just have to look them up if somebody doesn't tell you to. Pause if you need to keep taking notes. Okay, let's try a simple one. So the Mars Climate Orbiter, here's a drawing of the Mars Climate Orbiter. Maybe what it would have looked like if it hadn't crashed into the ground. Its mass was 638 kilograms. What was its weight on Earth in pounds? What was its weight on Earth in pounds? And the conversion factor is 1 kilogram is equal to 2.2 pounds. kilogram is equal to 2.2 pounds. So how are we going to do that? So here's what train tracks look like. Train tracks are basically a longer horizontal line, and then we stick a vertical line in there, and then we see how many we need. So our starting unit is kilograms. So I'll put that on the left. I'm going to go left to right. And our finishing unit is pounds, right? So I'm going to put so that it's in the place where it needs to be at the end. I'm going to say LBS, that's our abbreviation for pounds, right? So we know we have a certain number of kilograms and we want to get to a certain number of pounds. Okay, well let's start off with what we have. We know we have 638 kilograms as the starting mass. And what do we need to do to get to the final pounds, right? So this is our unknown, that's the final pounds. Well, we can put in our conversion factor. And how do we know which way to put it in? We look at where the units are. So in order to get to pounds, we're going to need to put kilograms underneath so that when we do the math, the kilograms will cross out. So above and below, it crosses out. And then we'll put pounds up here. And what is our conversion factor? Well, we put the 2.2 with the pounds. 2.2. And you don't have to write it, but if it's a 1, but we'll put 1 there. Right? So it's 638 kilograms. 2.2 pounds per kilogram should give us a certain number of pounds. So now we simply multiply it, right? If it was down here, we would divide, or we would multiply by the fraction. But here we can just multiply straight through. 638 times 2.2. So 638 times 2.2. Now's a good time to pull out a calculator. I have a calculator right here. And 638 times 2.2 is equal to 1,403.6. So our final answer is 1,403.6 pounds. We crossed out kilograms. We were left with pounds. 1,403.6 pounds. Okay, let's try another one. The Mars Climate Orbiter took 286 days to go from Earth to Mars. How many minutes was that? So I don't give you any conversion factors in this one because hopefully you know these conversion factors. We just have to remember how many conversion factors there are. So this is just basic time stuff. Let's set up some train tracks. Train tracks. What are we starting with? Well, we're starting with a number of days. And what are we ending with? We're ending with a number of minutes. So let's see, how do we get from days to minutes? Well, first we want to go from days to hours. It's hours, days, so we need the conversion factor there. And then we want to go from hours to minutes. So put minutes there, hours here. Remember, I'm doing it this way because if I put it above and below, it's going to cross out, and we'll be left with whatever isn't crossed out, which is the thing that we want, right? So now we can just put in some conversion factors. How many hours in a day? Well, that's 24. 24 hours in one day. How many minutes in an hour? Okay, well, that's 60 minutes in 1 hour. And our starting number was 286. 286 days. So now, we just have some math to do. 286. Oh, sorry, I forgot to do this. To make sure that we've done it right, do the days cross out? Yep. Do the hours cross out? Yep. Will we be left with what we wanted to? Yep. So 206 times 24 times 60, and that's a big number. It's 411,840 minutes. There's your